memorize. So if you memorize this double angle, you don't even have to memorize the difference. You don't have to memorize any of the new ones after double angle. Double angle is the last one that I expect you to memorize. So, yes, and you'll have these identities. You'll have all of the identities except the ones you had to memorize for that memorization quiz. Double angle. Those are the only ones that I expect you to have.
So what's the point of this?
Yeah.
So if you forgot to write it down from the class, basically
you'll get one of those in calculus too, and it's pretty much everything you need to memorize.
You know the keys for it.
We are students here.
No, all of them. Okay, which side did they choose?
Left. Distribute. Dude. It's a bad word.
She'll know what you mean.
Are you sure?
And I hit the stores.
Oh.
Cosine squared plus sine squared is 1.
1. Yeah.
And 2 sine of x cosine of x is?
Sine
Any questions about that one? Okay, so sometimes we have things like sine of 4x that we need to break out, whether it be in an identity or not in an identity. I think you have a proof with something like that in it that you're going to have to figure out. So how could I break up sine of 4x? And it says express the function as a trig function of x. And what that means is no 2's or 3's or 4's, just sine of x. So how could I get that to be just x? Where would I start?
I say you make it 4 sine theta and
Sine 4.
cosine theta.
Plus.
Okay. Either sine of 2x plus 2x or sine of 2 times 2x. You can either go with the double angle identity on this one since it's an even number, or you could go with a sum and difference. It's up to you. I'm going to go with what Anna said. She said it. So, she said to break it up into sine of 2x plus 2x, which would be sine of 2x cosine of 2x. Now, because these are both the same thing, you couldn't do this with everything, but because those are all the same thing, are y'all okay if I go ahead and write that as 2 sine of 2x cosine of 2x? Which you can see now what I mean by we could have used the double angle identity.
Do you not have to put a 2 in front of cosine?
What's the identity? Well, oh, you mean from just where I added?
Yeah.
There's, when you add, this is like 1 apple and 1 apple, and I add them together and get 2 apples. Like xy plus xy would just be 2xy. So that makes sense. Okay, am I all the way down to just x yet? No. So what would I need to do? Can't do that.
You can,
What do you mean trig? I agree. That's great.
yeah,
Use another double angle identity. In fact, 2 of them, right? I have the sine of 2x and the cosine of 2x. So for the sine of 2x, I'm going to write that part in red so you don't get lost on what I'm doing. 2 sine x cosine x. And then we'll put the other part. Cosine of 2x. I have 3 options. Does it matter which one I choose?
Whichever one's easiest to use.
It doesn't matter. Now, will it matter if this problem turns into a proof problem? Yes, you'll want to pay attention to what the other side has in it and choose wisely. This one, it doesn't matter. I just need to get my x's so I can pick any one of the. That's great.
I understand.
There's not.
No 2x's, no 4x's, it just wanted
Actually, just
it's so
you know, you want
same thing on the next problem, right? Cosine of 3x in terms of just x. This one I cannot use a double equal identity from the beginning. So everyone agree with that?
yeah.
Because it's odd. So you can't, I guess you could do 1.5, but that wouldn't get you anywhere
It
good.
was, or you
Right. So on this one, Anna picked a sum identity, but I say from here to here, technically you could have just gone straight with that line. But this one we would have to do cosine of 2x plus x or x plus 2x, either way. Which is cosine of 2x cosine of x minus sine of 2x sine of x. Any questions so far? Okay, which ones do I still need to break down? The ones with 2x's in them, so I need to get a cosine of 2x broken down. Again, this doesn't give me another side of an equation or any other. Oh, it does. It tells me in terms of cosine of x, doesn't it? So which identity would I want to use if I want this only in terms of cosine of x?
2 cosines.
On this one, sine of 2x is 2 sine of x, cosine of x. Okay. Now, since it said to write it in terms of only cosine of x, right now I actually have a sine squared over here, don't I?
Yeah.
That's fixed pretty easily. Where I see the sine squared, what am I going to replace it with?
Cosine 2x. Wait.
What is the identity for sine squared if I'm going to change it into cosine?
One last.
Again, I could simplify, and again, if I turn this into a proof problem, you will need to simplify. But for this, it just said get it in terms of cosine of x. Have I successfully done that? Everything in my function now has a cosine of x in it, so I would say I'm done. Quit now. Any questions about that? Does that help on that proof problem you have on your homework? Okay, this is another question that your homework asks you. Use trig identities to graph the function without a calculator. Your bag is hanging there and your stuff is in there. I don't know how to graph a fourth power trig function. Do you?
Put it up.
You don't actually.
Simplify it.
What is the only kind of trig function I do know how to graph? Just sine like I could do a phase shift, period change, amplitude change, all of those things, but that's it. Just sine, cosine, tangent, that's all I got. So I probably need to simplify this using an identity. What's the first thing that I can do? Difference of perfect squares. I have to give this one more thought. Yeah. What is cosine squared of x plus sine squared of x? And what is cosine squared of minus sine squared of x?
Cosine 2 cosine 2. R is for x.
Can I graph that? Can I graph that? Cosine with period change. That's it, right?
Yeah.
Totally doable. The first one not so doable. This one very doable. Cosine of 2x.
Yeah.
This is an identity. And then cosine squared is 1. Quick reminder. Okay, cosine graph with period.
No, 2 pi.
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 Okay, it's 2 pi over 2.
2 pi over 2. So pi is my fourth sigma cosine.
Alright, didn't you take this away?
Yep.
So really easy to graph by hand. If I change it, very difficult to graph. If I leave it as cosine to the fourth minus sine. Questions about that one? Does that help you with the graphic problems on your homework? I don't know what you're looking for on those. Some more verifying. You'll need to see some more verifying for you.
Yes.
The first thing I would probably do is go with the left-hand side. Maybe, I don't know. What do you think?
That's the left hand.
Okay, you might want to change the right-hand side into sine and cosine. Okay, do that. If you like that.
That's the left side.
Is there a wrong choice?
Yeah.
No, because if you don't get somewhere on one side, we'll just switch to the other one and work. Common denominator. Is that what you would do? So this one needs a cosine, so I get cosine squared minus sine squared over sine cosine.
Cosine 2.
That bottom is almost
Yeah.
sine 2 theta, isn't it? It just had a 2 there.
Yeah.
And I just put a 2 in because I feel like it.
So the multiply the top and
I'll
bottom.
probably do that.
But I can multiply the top and bottom, which really works out nice because there's random 2 at the top.
Look there. I did it right.
Yeah, you did.
But I can
Crazy.
2 and cosine squared minus sine squared is
Cosine 2. Theta.
I think we're there, isn't that what we're looking for?
It is. Yeah, but you know, the left side probably.
Oh, you see, when you ask if you just put it 2 there, that's probably what I did. Yeah, the question mark like this. Where did you get that outside? Oh, the other side had a 2, so I decided to count on top.
But if you put 2 on top and bottom, I feel like that's right.
That's right. Hopefully the
That's why you don't skip steps, because if you skip steps, I'm going to go, what happened in between here?
Yeah.
It is general magic, yes.
I make up some new thing.
Okay, which side on the next one?
Left.
Does it matter?
Yes.
Does not matter.
No, let's go right.
Yeah.
Let's go right.
If you were going to do the right, do we have an identity for cosine 2x? I mean cosecant 2x, right? No, what am I going to have to change that to before I would have to change that into 2 over sine of 2x to work with it, and that would be a great idea. I think that's a great plan,
That's fine.
but you would have to change it that way. If you work with the left,
Alright. Let's go.
does it matter?
No. But it's just left.
Common denominator, I would get sine squared of x plus cosine squared of x over sine of x cosine of x, which is 1 over sine of x cosine of x.
Maybe the left is better.
And then what do I need to do to make that be 2?
Multiply by 2.
Multiply by 2 on top and bottom. And if I do that, I get
2
2 over sine 2 theta.
okay. You could have definitely worked with the right hand side. It doesn't make any difference how you do that. Any questions about that?
Speak your mind.
Is this helping with your homework?
Yes.
Yes.
More problems.
Okay. This is on It's on your piece of paper. You don't have to write it down. It's just another set of identities that exist. And it is essentially taking the double equal identities, kind of undoing some of them, and going backwards. But the sum to product, product to sum are just, if you have two trig functions added together, you can turn them into a product. Or if you have two trig functions multiplied together, the product to sum changes them into addition. Sometimes it's nicer to have multiplication. Think factoring, right? That's what you're doing when you factor. You're turning things into multiplication. And then sometimes it's nicer to have addition, and so that's where some product to some identities come into play. So I'll show you an example. This is cosine 3 theta plus cosine 7 theta. So I am using this identity. Thanks for see. And so, looking at your sheet, what would this be?
2 cosine of 30 plus.
Of what?
30 plus 70 over 2.
Why you guys?
Alright. 3 theta plus 7 theta.
He was doing it right, I think.
Oh.
Which is 10 theta over 2 or 5 theta? And negative 4 over 2, which would be and if you saw this, now this answer's fine based on the question, no problem. But that would also be equivalent to this. Why would it be equivalent to this? The negative equal identity or even odd identities. Either way it would work. Any questions about that one? That's how sum to product works. The other set is product to sum. Again, you have these written down. It is essentially backwards of the last set of identities. Again, they're not ones that AP practice expect you to memorize, so I don't expect you to have them memorized. I just want you to know they exist. Be able to look them up. Any questions so far? Alright, so how that would work is I have a product 6 sine of 40 sine of 15. Well, that's something that looks kind of like this one, right? Now there's a random 6 in front. I'm going to ignore the random 6. I'm just going to look at the sine of A, sine of B, right? Because there's not a 6 in front of my identity. That makes sense. Are y'all looking at this identity on your paper? I have a random 6 in front. Then it's 1/2. You tell me. Does everyone see where he's getting this? Me? Three. Do I need those parentheses? Yeah, the 1/2 goes with everything in that identity. But I could go ahead and multiply the 1/2 by the 6. So that would be 3 cosine of 25 minus cosine of 55. So that is how the product to sum works. So we took a product and made it a sum. You could, but you don't have to. Just write it as a sum. If the it's not any problem.